draw caffeine here using the Schroeder Diamonds. So what we see is a two-ring structure. Gotta move that a little bit closer here. So we've got carbons and nitrogens. So we're going to start with the two. Back that up a little bit. Let's get this a little bit better here. So what we're going to focus on here, the markers. Now we got a two-ring structure. We're going to do carbon and nitrogen is what we're going to be focusing on. When I look first off, I see that there's going to be a triangle, and there's going to be another triangle, more of a festive atmosphere here. So two triangles here. There's going to be a diamond in between them. So we'll put the diamond. What the diamond has actually is a double bond of this. So we're going to draw one that way, one that way. One goes down there. These go to now are two more diamonds. So there's a carbon. Here's a carbon. Drawing these kind of close because it's going to be a ring structure here. So we know there's one bond that goes over there, so we'll just draw one now. Now look what that does. That finishes that in. So if you wanted, you can color that in. Little confidence builder lets you know you're done with that carbon. If you really wanted to, you could draw your hydrogen in here and finish that carbon off. So see, it'll be a little tool for you here to gain a little confidence. Because these are some big molecules now. We look at this here. This goes to a methyl group. So look, there's a diamond. It's a methyl, so we could just put our three hydrogens around that. 1, 2, 3. So the beauty of this, we're a little intimidated, we'll just color those in and be done with them. That carbon's got 4 on it. Nitrogen's got 3. So see that? We're done with those. We don't have to worry about them now. When we look in here, it's a ring structure. There's going to be a double bond here. So look, there's... How can we do this to make it the best here? This is going to have to go up to a diamond. This is going to go down to a diamond. So draw the diamond in now. Now a double bond to this guy is why I'm hesitant to draw him in. That doesn't look very nice, does it? But anyway, we're done with those. So color them in so we don't have to come back and see. Okay, let's do this. Here, I worked it out. See, this will give you a negotiating power here, too. See, I'm learning this with you. That's why I think it's good. We'll take this nitrogen to that side. Now we can do our double bond that way and make the top up here go to that. Isn't that cool? See the way we corrected ourselves? Because we're learning. We're learning how to do something. Actually, this up here gets a nitrogen, so it's only a triangle. It's no big difference. So there's a triangle. This carbon here goes to a nitrogen, so there's a triangle. And see, we'll learn from experience which way to move the triangles, face them this way or that way. And to make a 6-membered ring out of that, we've got 2, 4, 5. Must be a carbon because there's usually only 2 nitrogens at most in any of these ring structures. What's our rule? If we can, try to always bring a carbon, well, that's a carbon-to-carbon bond, so that doesn't matter, but to the side. Makes it easier to work with. That's leave you hanging there. So this is looking really sloppy, but this is a big molecule here. This is caffeine. C-A-F-F-E-I-N-E. Think anybody ever lost a spelling bee from caffeine? Where they always say I before E. Well, except after F. My always joke was I before E, except in Einstein. Twice. Same with Budweiser and Heineken. Now this nitrogen up here goes to a methyl. We're getting better now. We're not the beginners, so we'll just draw it with no line in there. We'll just draw the diamond on top. So what does that do to the nitrogen? Gives it its third bond. So color in the nitrogen. Oh, we colored in that carbon, so it's a methyl. So now we're in such a good habit here. We know the methyl has the 3 H's on them, so there it is. We'll clean this up a little bit. This is our warm-up anyway. That's why we're doing caffeine here. So as we're coming around the structure here, what we get to see is going to be an oxygen on this here. So let's draw this that way. And we're finished with that carbon now, so color it in. This is a fun little technique, isn't it? As soon as you're done with it, you color it and you're done. Half this molecule all on this side. We're done with it. And look how complicated this is here. These are ring structures. I'm sorry, this nitrogen here gets a methyl. What do we know a methyl to be now? A diamond with a bond to something else, so 3 of these get proton dots. We're down to methyl. It's a simple group now, isn't it? And you know what's neat? It's methylation in DNA that activates the DNA. So that's, if you go into research, that's the big hot territory right now. Nitrogen there, it's got its 3 bonds. Color it in. Huh? So what are we left with here? We're left with a carbon up here. And other than that, folks, this is, we get to color in the oxygen too, right? Huh? So, see, we're developing this as we go along. So the O's are always going to have to be colored in the carbonyl or ether phase. So what actually happens with this carbon up here is double bonded O. 2 bonds for the oxygen, so there you go. Color it in. What do we do for that diamond? Color it in. There you go. That's your caffeine molecule. Okay, we're going to do some with the lighting here, so we're going to take a little break. Okay, we're going to try something new here. We're learning these molecules as we go along, so I'm going to learn it with you, folks. Right now we're going to do pyruvate and compare it to lactate. So all it is 3 diamonds and one of the diamonds is a methyl. So what do we do on these? It's easiest if we connect them in the middle. We'll even draw lactates here. One, 2, 3. 1, 2, 3. This is the reaction that happens when you're breaking down your glucose. Splits it into 2 pyruvates. If there's not enough oxygen around, this is when you're burning your muscles. Not enough oxygen, goes to lactic acid.